This perfect circle of light shouldn't exist. Astronomers call it an Einstein ring, a distant galaxy stretched into a glowing halo by gravity itself. But the ring you're looking at right now has a problem. To be this bright, this smooth, and this perfectly aligned, there has to be an enormous amount of invisible mass sitting in exactly the right place. And the more the James Webb Space Telescope studies it, the less sense it makes. Either our ideas about dark matter are wrong, or the universe is hiding something much stranger behind this ring. Let me show you why this simple circle of light might be one of the strangest objects in the sky. To understand why this ring is so weird, we first need to talk about what it should be. Imagine you're looking at a street lamp through the base of a wine glass. The curved glass bends the light, stretching it into arcs. Or, if everything lines up perfectly, a full circle. In space, massive objects do the same thing. Not because they're made of glass, but because gravity bends space-time itself. If a huge galaxy sits directly between us and a galaxy much farther away, its gravity works like a cosmic magnifying glass. The background galaxy's light is forced to curve around this invisible valley in space-time. And when the alignment is almost perfectly straight, we see a glowing circle. An Einstein ring, one galaxy behind, one galaxy in front doing the lensing, and us, sitting exactly on the line. Most of the time we only see twisted arcs or smeared streaks of light. To get a ring this clean, three things have to line up with astonishing precision: the background galaxy, the lens galaxy, and us. That alone makes them rare. But what James Webb is seeing in this particular ring suggests something even more unlikely is happening. This system is known as JWST R1G. The light we see from the background galaxy began its journey more than 12 billion light-years away, when the universe was only about a quarter of its current age. At first glance, it looks like a textbook example. A bright lens galaxy in the middle and a nearly perfect blue ring wrapped around it. But when astronomers started measuring it carefully, the puzzle began. By modeling the shape and brightness of the ring, we can work backwards and calculate how much mass the lensing galaxy must contain. And in this case, it came out to several times more mass than you'd expect from the stars and gas we can actually see, roughly 6 times more than the visible matter alone can account for. Now, that's normal to a point. We already expect extra hidden mass. We call it dark matter. But here, the amount of dark matter needed is unexpectedly high, almost suspiciously high. And it's not just the amount, it's how the mass has to be arranged. To produce a ring this smooth and this bright, the invisible matter must be packed in an unusually compact, concentrated shape. Far more concentrated than simulations predict for a galaxy at this point in cosmic history. In other words, when we let the ring tell us how much gravity is there, the numbers don't match our models. It's like weighing a person and discovering they somehow have the mass of a car. So what's going on here? Either we're misunderstanding what dark matter is, or this galaxy is hiding something we didn't expect. Dark matter is already the universe's biggest missing puzzle piece. It doesn't shine, it doesn't glow, and it doesn't interact with light. The only reason we think it exists at all is because of its gravity. And that makes Einstein rings one of our best tools for mapping it. They're like cosmic CT scans, tracing the hidden mass surrounding a galaxy. But this one ring, and a few others JWST is uncovering, are starting to suggest that something is off. Maybe our dark matter models are too simple. Perhaps dark matter isn't just a passive cloud, but can interact with itself in subtle ways, clumping, scattering, or forming structures we haven't accounted for. Or maybe the galaxy doing the lensing is hiding extra compact objects, a swarm of black holes, dense star clusters, or something more exotic, quietly boosting its lensing power. And on the more radical side, some physicists wonder if gravity itself behaves slightly differently on the largest scales. That doesn't mean physics is broken. It means Einstein rings act as stress tests. If our theories survive, great. If not, we learn something deeper about how the universe works. This is why astronomers are obsessed with finding more of these systems. With Hubble, we saw the broad strokes, the big arcs and rings. With JWST, we can finally see the tiny wiggles, the small distortions caused by clumps of dark matter no telescope could detect before. Each new lens system is like adding a new data point to a cosmic X-ray of the dark universe. The more we find, especially ones that look impossible, the closer we get to discovering whether dark matter is stranger than we thought, or whether we've been missing something even more fundamental. If enough of these impossible-looking rings keep turning up, we'll be forced to admit something big. Either there's more in the universe than we can currently see, or gravity itself doesn't work quite the way we think. So what would you bet on? A strange new form of dark matter, or new physics hiding in plain sight? Let me know in the comments. And if you want another James Webb mystery, one that breaks the rules even earlier in cosmic history, check out my video on the bizarre red dots JWST found in the baby universe. It should be on screen now. Thanks for watching.